Hello, this is Aziza, and this is ML2 final project presentation by Team Tenet. So our topic is a Santander customer satisfaction. From the frontline support teams to C-suites, customer satisfaction is a key measure of success. Unhappy customers don't stick around. So what's more, unhappy customers rarely voice their dissatisfaction before leaving. So in this project, we work with hundreds of anonymized features to predict if a customer is satisfied or dissatisfied with their banking experience. The task is to predict the probability of each customer in the test set being unsatisfied. When we started working with the data, we observed some problems. One of them was a data imbalance. So we had about 96% of data were belonging to a class 0. And we had a collinearity where a lot of features were highly related with each other. And the large number of features that we had, about 369 features, and a lot of these features were whether constant or quasi-constant. For dealing with the imbalance, we used SMODE to upsample minority class so that our data has equal distribution of classes in trained set. Doing so, this makes sure that our model is less biased towards majority class. So SMODE is an improvement over minority oversampling. SMODE works by selecting examples that are close in the feature space, drawing a line between the examples in the feature, and creating a new sample at a point along that line. As we have a lot of features, we'll have to eliminate those with the high collinearities. We should be very careful while doing it. So here we have about 369 features. Around 100 of those by inspection are constant or quasi-constant. So we use a lasso pass to eliminate variables for us. So in this graph, you can see that how increasing the values of the alpha drives down the number of non-zero coefficients. We went from about 369 variables to around 70 variables. Although lasso has eliminated most of the collinear features, we still see some high correlations in the heat map. So we are going to keep them for now, as we cannot always eliminate all the correlations without losing a significant amount of information. So to make sure that we did not lose a lot of information while feature selection, we fit two random forest models. So first, we fit to data with all features. We get an AOC curve about 0.79 and F1 score of about 0.24. Then we fit another random forest model to choose lasso features. Then we get about AOC curve about 0.80 and F1 score of about 0.23. So not only did we not lose information, but also improved on our AOC score. Model trained on lasso features is definitely the better model here. Jamil?
So we did some basic EDA and observed high zero inflation. Our first base model is logistic regression. It performs poorly with the AOC of 0.63 and an F1 score of 0, which was always classifying as 0. Then we did second baseline model, which is a decision tree, and it improved on the last with an AOC score of 0.8 and an F1 score of 0.2. Then we did a random forest model, and we beat the baseline with an F1 score of 0.23. We also tried AdaBoost, which performed almost similar to random forest with the AOC score of 0.8 and F1 score of 0.23. Here we compare the different models on the various metrics. Random forest outperforms everyone in terms of precision and F1 score. AdaBoost outperforms everyone in terms of recall, very naive model which always says zero still has the highest accuracy. Now let's interpret what's happening in random forest. Indian?
When we do default random forest importance, we see that as many as 5 variables have high importance. But as we know, default tree importance can often be misleading as we know. So we will also try permutation importance. A lot of important features as suggested by random forest default importance vanish in permutation importance plot. Variable 15 and variable 36 have high importance than other variables. We do PDP plots to see how predictor probability depends on individual variable. We see that most curves become flat after a certain value after 0. We see a increasing trend in graph for variable 36. For variable 15, graph rises for a while and then plateaus. So here are our conclusions. We studied Santander customer satisfaction dataset. We observed a lot of feature which we see either constant or quasi-constant. We dealt with correlation using lasso path. When a non-trivial model was trained on around 70 features selected by lasso path, it outperformed other model trained on all 369 features. We beat baseline effort score by a small margin. We plotted various ROC curves and our best area under curve score was 0.82. We plotted importances using random forest default importances and permutation importances. A lot of features which were tagged as important by random forest were found not very important in permutation importance graph. Due to very high zero inflation in almost all features, PDFs, PDPs may not be very accurate. Yeah, thank you.